Today we're talking about simulators, and here's why you should care about them. Last week we talked about the crash of an Epic E1000 at Steamboat Springs, Colorado, that flew an advisory glide slope below the MDA and crashed into a mountain. So if you don't understand advisory glide slopes and when you're allowed to descend below the MDA, please listen to that episode at aviationnewstalk.com/414. Now, if that pilot had flown that approach in the simulator ahead of time, he would have known about the issues with flying the approach and would have flown it differently. Coincidentally, I was in Austin, Texas the day before the accident and was lucky enough to visit the Redbird Flight Simulations factory. And in a moment, I'll be giving you a tour of that factory. I was visiting with COO Josh Harnagel, and here's what he said just 12 hours before that crash.
But instrument currency is honestly a big point on those for sure. We have lots of folks that buy them for that. And to shoot an approach on the sim before they go do it in the airplane as a general rule. Like, I don't shoot approaches that I haven't flown before.
Yeah, that's a great way to go. Every year when I have to go back for my annual recurrent training in the Vision Jet, I always go into just a local ATD simulator, which is somewhat generic, but I find it's really useful just to get in there and kind of remember some of the funny little gotchas that you find in the instrument world. Now, I mentioned that I always get some sim time before going for my Vision Jet annual recurrent check. What I didn't mention was that I remember a couple of years ago when flying in the sim ahead of time, that the one big thing I took away from my time in the sim was that it reminded me that when flying an LNAV+V approach, the autopilot would take me through the MDA. So simulator time is extremely valuable, both in getting a certificate or rating and also in staying current. So stick around for our fun factory tour. Hello again, and welcome to Aviation News Talk, where we talk general aviation. My name is Max Trescott. I've been flying for 50 years. I'm the author of several books and the 2008 National Flight Instructor of the Year. And my mission is to help you become the safest possible pilot. And if you're new to the show, welcome. Glad you found us. And now, if you would, in whatever app that you're using, touch either the subscribe key, or if you're using Spotify or the Apple Podcast app, the follow key, so that next week's episode is downloaded for free. And see if you know any of these great people who just recently signed up to support the show via Patreon. I greatly appreciate Patreon donations, as they're smaller, reoccurring donations, much like the subscription you may have to Netflix or some other streaming service. So my thanks to William Polk, Harold Albright, Bradley Shipp, Doug Olson, Steve Barsh, and Steve Podrachik. We also had some one-time donations via Venmo. Think of these as what you might pay to fly a plane with an instructor for an hour, which is sort of what you're doing with me each week. Our thanks to Shane McFarland, Adam Tash, Lawrence Balter, and Mike O'Hara. And if you've been listening for a while and the show has helped you fly safer, let me ask you for your support. Aviation News Talk is a listener-supported show. There's no big company. It's just me bringing you episodes week after week. So if you thought I'd like to support the show someday, well, this might be your moment. Head on out to aviationnewstalk.com/support, where you'll find 4 options for supporting the show. And when you do, I'll read your name on the show. In a moment, we'll get to a few of your emails and our main topic in just a minute. But first, and now here's a Headset Minute by Lightspeed with Derek Schmidt. Derek, at non-towered airports, we often have to use a cell phone to call for clearance. And if the engine's running, that's a noisy environment. Tell us what Lightspeed has done to help pilots make these calls sound better.
Well, as cell phones use has become more common, aviation headsets will continually offer ways of integrating that technology with the headset to help pilots more seamlessly navigate situations like a clearance call at a non-towered airport. Initially, connecting to a cell phone required an audio cable and the hardwire connection between the two devices. With the introduction of Bluetooth technology, headsets and cell phones can now pair to one another wirelessly, enabling pilots to make cell phone calls without adding another cable to their cockpit. Work has also been done, though, to improve the quality of those cell phone calls made over the headset. Most premium aviation headsets on the market have exceptional clarity of communication over their microphones. The Zulu 4 headset, for example, is able, during a Bluetooth phone call, to listen for background noises in the environment and eliminate them during the phone call. This clears up communication, so operators receiving phone calls will hear the pilot's voice and not the engine and cockpit noises during the call. The aim is always here at improving safety, as missed and garbled communications can delay clearances or add stress during the critical phase of flight.
And this really works. I was checking out the Zulu 4, and I gave my friend Rob Mark a call while we were taxiing. He said he couldn't hear the engine at all in the background, so great job on designing this new technology.
Well, I'll let the engineers know.
Derek, thanks so much for joining us here today.
Yeah, happy to be here, Max.
And now let's get to the good news. First, congratulations to Chaz Ryan. He says, hello, Max, and thanks for all that you do. I began listening to your podcast when I was working on my IFR in 2023, and a few weeks ago, I earned my CFI certificate. Thanks so much for keeping me motivated and informed. Even as a new CFI, I feel that I have so much to learn. Congratulations, Chaz. And yes, that's the approach all pilots should take. Always be trying to learn new things. That's what helps keeps us safe. And here are a few of your emails. Most of these relate to last week's episode about the epic E1000 crash in Steamboat Springs, Colorado. John Hummer wrote, so glad you're doing this. You will save lives for sure. Just so sad. My best friend is a TBM pilot. I'm the godfather of his daughter. We constantly tell each other we never have to be anywhere. Max, not sure if you remember this, but the first time I saw this phenomena was in my commander doing the 3-1 X-ray approach at KSUN. MDA is 6,180 feet. Airport elevation approximately 5,300. I remember flying it, blew right through the 6,180-foot MDA on an advisory glide path created by my STEC 2100 autopilot. I wrote you about this then. Here we are a few years later in this tragedy. Thanks from all of us for talking about this. It's not taught well enough. Thanks again and be safe. Well, thanks so much for that, John. And here's an email from Brett West in upstate New York. He says, hello, Max. Outstanding podcast concerning the epic E1000. Never has one of your shows been so full of useful, rarely covered yet highly necessary information. I'm a Vision Jet owner pilot with more than 2,000 hours. I am horrified that until this podcast, I have never noticed or understood the notes in non-precision approach charts that read visual segment obstacles 34-1 not clear. This was just one example of many terrific critical nuggets that I've picked up. I have never answered your calls for financial support, but I've decided to chip in for the cause. You have earned it. I do, however, have one correction for you to consider. You stated, typically the vertical path starts at the FAF and extends to either the missed approach point or to 50 feet above the runway where vertical guidance ceases. The signal is shut off at 50 feet AGL to prevent pilots from attempting to fly a WASP signal down to the surface in 0-0 conditions. This surprised me as I have never noticed the vertical guidance shutting off below 50 feet, but then again, my eyes are where they should be outside the cockpit at 50 feet. I record every flight I make on GoPros solely for my own debrief, so I went back and looked at a number of those approaches in my G3000 G2 Plus Vision Jet, and in every case, the vertical deviation indicator remained alive until the weight on wheel switch was detected, which would be when the aircraft touched down. The only thing I can think of is perhaps the 50-foot rule is suspended in Autoland-equipped aircraft. Makes sense that Autoland would need guidance all the way down. Thanks again, Max. Keep them coming. And the 50-foot item was something that I first wrote about when I put out my IFR book in 2009, and maybe things have changed since then. So thanks so much for your comments, Brett. And here's an email from Doug McElveen in Louisiana. He says, hi, Max. I watched your Patreon video of the simulated flight into Steamboat Springs and had a few questions. And by the way, I've just made that video available for everyone to view. It doesn't matter if you're signed up on Patreon or not. Just head on out to patreon.com/aviation news talk and you'll find it there. And while you're there, consider supporting the show. Doug continues, I don't understand why the simulator was not providing audible terrain alerts while you were flying toward the mountainside. Isn't that the purpose of TAWS? Do you think the Garmin G1000 in the Epic would have been providing terrain alerts to that pilot in the real aircraft? Yes, Doug, I think that is indeed possible, but I don't know for sure. And certainly the simulator that I was flying doesn't replicate everything, so that may be why there were no alerts. And by the way, some of those alerts are shut off as you get close to airports, though this accident occurred about 3 miles away, so I don't know if it would have been shut off. Doug continues, also, why do you think Garmin provides an advisory glide path on that GPS approach if it ultimately leads toward rising terrain? I've flown LNAV approaches where there is no advisory glide path, which keeps the pilot high and requires a manual descent. I'm not sure why they would include an advisory glide path that allows the autopilot to couple, knowing it flies into a mountain. I would really appreciate any thoughts you might have. I love your show. I've learned a lot and truly feel I'm a safer pilot. Thanks so much, Doug. Appreciate that. And I can't tell you why advisory glide paths that fly through mountains are available. There was a gentleman who wrote to me a few years ago in New York who commented that he got extremely close to terrain. And when I flew that one, the simulator, it did hit the mountain there as well, too. So this is something that's been well known by folks who are conversant in advisory glide slopes, that you cannot trust them below the MDA. And of course, below the MDA, you have to be visual anyway. So yeah, it is kind of unfortunate they exist. I think a better solution might be to either cut them off below the MDA or to flight check all of them so that none of them go through terrain. And by the way, just in the last week or so, the FAA has notumed that particular approach into Steamboat Springs as being not available. And that's, I think, notum through September or October. So clearly they have decided to go and reevaluate that approach. My guess is that it meets all of the requirements, but that unfortunately it leads to disaster for people who do not precisely follow the non-precision approach rules. And here's an email from Chris Thavasan. He says, Max, I've been a long-time listener and appreciate your comments on COPA, that's the Cirrus Owner Pilots Association, from time to time. Writing to you about the Epic crash. There seems to be a lot of focus on understanding the +V mode, and yes, that topic deserves focus, he says. However, there is also another subtle aspect at play, and that is even if we as pilots are experienced, proficient, and know everything, it can still happen to us. Yes, that's why we need to always be vigilant in the cockpit. He continues, the case and the point being knowing where to look, how to confirm, and actually confirming our planes are doing what we expect them to. As instrument instructors, there's a lot of focus on the scoreboard enunciations. So that's the listing of the autopilot modes at the top of the PFD. He says not enough focus on the HSI enunciations, checking the approach we're flying and noticing whether or not it's a 2D or 3D approach with and without a real glide slope or glide path. One small mistake or high workload would be enough to kill us. And that could happen to anyone, regardless of knowledge, experience, or number of hours of proficiency. Not speculating, because we don't know what really happened to the pilot on this flight and whether or not this was a lack of knowledge or simply an oversight. Thank you again for what you do to further safety in aviation. I've learned a lot from your shows. Cheers, Krish. And Krish, you raised an interesting point. Let me just kind of delve into that a little bit more. What you're saying in essence is that pilots are not looking enough at the letters that appear inside the HSI as they fly the approach. And I agree. I am guilty of that as well. These letters really don't draw your attention as much as they should, and yet they're critical to understanding what level of minimums have been approved for the approach that you're flying. For example, many approaches will have 3 different sets of minimums that you might see. Typically we see LPV, but it's possible we could also see LNAV/VNAV or LNAV depending upon the satellite signal quality. And if you're not looking at that, and that would usually update right after the final approach fix becomes active, which means you've just crossed the fix preceding it, that's the time to look at the HSI and see, hey, what minimums did I get on this particular approach? And I'll talk to you in a future episode about the experience I had at Hayward, California a few weeks ago, where I didn't get what you typically get on that particular approach. Now here's an email from Douglas Cole. He says, I've been listening now for several years, but episode 414 explaining the epic crash at Steamboat was a lifesaver in so many ways, highlighting the subtle difference in LPV versus +V advisory glide path. I'm a 50-year-plus pilot with years of commercial steam gauge experience, still trying to learn the intricacies of modern GPS navigation. Despite having studied several of your books, these kinds of details I consider hidden gems. The other episode was the Why Doesn't the Glide Path Always Capture? That was very helpful. Thank you. Thanks so much, Doug, and to everyone else who sent your emails. And for anyone who wants to contact me, the best way to do that is just go out to aviationnewstalk.com and then click on Contact at the top of the page. And before we get to our main topic, let me throw out one other perspective on the epic crash at Steamboat Springs. I've given it a lot of thought and tried to apply some of the things I learned at USC when I was studying accident investigation and SMS or safety management systems. One of the first principles of safety is that all workers make mistakes, but they shouldn't die or be injured because they make a mistake. We should design systems that are robust enough to fail without killing someone. Now, if this approach were being looked at by, say, the safety committee in a factory or at an airline, someone would have identified the kind of problem that exists with the advisory glide slope of the approach the pilot flew. And that airline or that factory would have done something about it. So, yes, that approach may meet all of the rules for designing an instrument approach, but those rules apparently don't consider that pilots are not savvy about advisory glide slopes and that autopilots don't level off at the MDA when following an advisory glide slope, something that many pilots don't know or expect. So yes, people knew this kind of problem existed with this particular approach, but apparently no one jumped up and down and screamed enough to have that issue rectified. And that's too bad. But it highlights a problem that we as GA pilots face when we fly for ourselves. We don't have a safety committee that's looking out for us, helping to identify hazards, working to rectify them, and communicating those issues to us. And that's one of the reasons that general aviation has an accident rate that's much worse than the airlines. And as you think about potential fixes, what comes to mind? Well, couldn't we design an autopilot that levels off at the MDA when it's following an advisory glide slope? Yeah, I certainly would think so. So let's get the FAA, the manufacturers, and everyone on board to fix these kinds of problems so that we don't have pilots dying simply because they make a mistake. And now let's get to our main topic. First, if you're interested in what's happening in virtual reality simulators, which is a little different than what we'll be talking about today, I encourage you to check out episode 124 of the Rotary Wing Show. In that episode, which I just released, I talked with the founder of Loft Dynamics. They have the only certified VR simulators in the world, and I've flown one of them, and it's amazing. Now, they started with helicopter simulators, but they are also working with Alaska Airlines to create a virtual reality simulator for an airliner. So check out that episode by searching in your podcast app for Rotary Wing Show, and I'll include a link in the show notes. Now let's talk about Redbird. First, I love factory tours, and over the years I've been lucky enough to have taken tours first at Piper, way back I think in the 1980s, then Columbia, and then Cessna, and then Cirrus, and even Continental Engines. That was a great tour. I've also toured, get this, a ladder factory in Bath, New York. And I learned about that last one through a book that I used to have that listed over 100 different factory tours in the U.S. But let's get on and talk about Redbird. Let me tell you first a little about Josh Harnagel. Josh is the Chief Operating Officer at Redbird Flight, where he runs the day-to-day operations and helps make sure Redbird is building products and experiences that actually matter to pilots and flight training organizations. Before stepping into the COO role, Josh led the sales, marketing, customer support, and customer success teams. He's a CFI and third-generation pilot. And now here's our conversation with Josh Harnagel. Josh, welcome to the show. So great to be here at your facility.
Oh, thanks for having me. I've been a fan and have read your books and listened to your podcast for a long time.
Well, this is just kind of a fun, opportunistic moment. I had a flight to Austin, and you very graciously, on short notice, agreed to host me here at your factory. Let's start a little bit about the origin of Redbird. When I walked into the lobby, I saw some intriguing photographs on the wall. Tell us about the beginning.
So in 2006, 2007 timeframe, our founder was doing some sim training at a big sim company for his King Air, and the experience was not great, and the sim was not great, but the company said it was a multi-million-dollar sim, and he had just retired from Dell and said, I could probably build something for less than that. So they got together and started working on building a sim. That was sort of the start of it, and they started with a Cessna Cardinal from a junkyard outside of Dallas. They brought the fuselage down and tried to build the sim inside of the fuselage of an airplane. And that's the name of the company, is Redbird for the Cardinal. But unfortunately, the sim doesn't really work very well inside of an old fuselage. We got to build the box ourselves now.
And tell me, what's the issue? Well, I would imagine most people think, hey, that would be the perfect vehicle for a sim. Why does an old fuselage not work well as a simulator?
Well, if you're only going to build one simulator, it probably works okay. If you're going to build more than one and try to sell it and support it and sort of standardize around it and make a business out of it, the variation between fuselages, the ability to acquire them, the customizations you're going to have to make over the course of your product is going to make it pretty unsustainable. But for one, if you just want one, it probably works okay.
I understand. So it's just not very repeatable, and you need repeatability in the business. That's great. Well, tell us a little bit about the different kinds of products that you currently have and also the markets that you're addressing with them.
Okay, so we have a range of simulation devices that are sort of small desktop units that an individual pilot or school could acquire, up through larger devices that have motion and move. We tend to hit the kind of entry range in GA, so your Cessnas and Pipers and Beechcrafts and that kind of stuff, single light piston, some like twin pistons. And then we go into the turboprop and light jet world. So we'll have King Airs, Cessna Mustang, CJ, but that's really where we top out, is sort of the light jet world. And we have everything from, like I said, small desktops that started around $4,000 or $5,000 up through larger units for like a CJ or a Mustang that might be $250,000.
And I remember some of the early simulators that I saw, and they included motion. And I think that's what distinguished initially this company from many other type simulator companies. Tell me how motion plays a role today, and roughly what percentage of the simulators that you ship include motion.
Yeah, so probably 70% of the larger units that we ship, where motion is an option, ship with motion. Overall volume, though, we ship a lot of smaller units that motion is not even an option. And I think it's particularly useful in situations where you're training brand new pilots that have no experience. It's a competitive advantage for some schools as well to be able to offer motion to their customers. So I think between those two things, that from a training perspective, I think certainly pilots that don't have a lot of in-cockpit experience, it will be beneficial for them. It'll help with the disorientation, that kind of thing, and preparing them for that. Your 10,000-hour airline pilot probably doesn't need it, but some people like it.
Let's talk about the low end, the kind of simulators that an individual might purchase. Tell me about the product names, the type of avionics they represent, and again, roughly the ballpark cost of each of those.
So we start with a product called the J, which is basically a pre-configured PC-based simulation. It's going to have generic throttle, generic yoke, a couple of switches, and that's going to start at, I think, about $3,000. And then we have an updated version of that that's got better graphics, and it all comes with the software installed on it. So you don't have to buy software, you don't have to buy a yoke, you don't have to do any, you just take it out of the box, plug it in, and it works. The J's and the J Velocity are not FAA-approved devices. Those are just a computer, right? And they're very popular with K-12 programs. High schools and middle schools have over the last 10 years, honestly, through the awesome work that AOPA has done on the high school education program, the high school STEM curriculum. It's become very popular in those environments, and we've certainly benefited from it, and we've sold a lot of J's. And then up from that, for sort of I would recommend, like what I have at home as a pilot, would be a TD, which is a tabletop design simulator. And there's two versions, a TD and a TD2, which the TD2 is just a complex, it has a prop knob and gear knob. And then avionics-wise, we'll have, for both of those, you have a G1000 or a 430-530 currently.
And then the TD and the TD2, what's the rough ballpark cost on those?
So the TD and TD2 are right about $10,000 once you get it installed and everything. And those are FAA approved. Those are basic aviation training devices. You can log your instrument currency in them without an instructor present. It can be quite beneficial. The hold especially always gets me. So I have to do a hold every 6 months, and I always end up doing it in the sim.
Yeah, it's true. We don't get too much holding in the real world. So the TDs, what flight simulator category do those fall into for the FAA? Are these AATDs?
Yes, they are ATDs, so Aviation Training Device Basic. So a BATD is the technical term. And then our larger sims, the motion ones, are AATDs, Advanced Aviation Training Devices.
And so for the TD, which is under the basic category, how many hours could you log toward an instrument rating in those?
For an instrument rating, it's 10 hours towards it, and none for the private, but 10 for the instrument, and I think maybe 20 for the commercial or something. You have to look. But instrument currency is honestly a big point on those for sure. And we have lots of folks that buy them for that. And they shoot an approach on the sim before they go do it in the airplane as a general rule. Like, I don't shoot approaches that I haven't flown before.
Yeah, that's a great way to go. Every year when I have to go back for my annual recurrent training in the Vision Jet, I always go into just a local AATD simulator, which is somewhat generic, but I find it's really useful just to get in there and kind of remember some of the funny little gotchas that you find in the instrument world. Well, talk a little bit about GIFT. What is that, and how does that play into all your products?
So GIFT is Guided Independent Flight Training. It's a collection of software and lessons, pre-programmed content lessons that take you through private pilot and instrument rating. We have 2 courses, private and instrument, that are maneuvers based. So it's not knowledge material, right? It's not going to prepare you to take the written exam, but it will prepare you to fly the airplane. And so on, private pilot, it'll be steep turns and slow flight and all that. On instrument, it'll be the different types of approaches. And what happens is there's a video that you watch, and then there's an instructor, a voice-based instructor in the sim that is watching how you're flying and will provide guidance. So if you're low, it'll tell you to pull up. If you're fast, it'll say, reduce power, whatever is appropriate given the situation. And then it grades your performance to the ACS standards. So at the end of the flight, you'll get a score based on ACS, whether you passed or failed, and it's quite strict. Unlike a DPE who's a human and will be like, hey, you were correcting, it's fine, you went 102 feet. GIFT does not do that. GIFT says you were 102 feet off of your altitude, you failed. The idea is that you can gamify your training and make it highly repeatable, so you get lots of reps doing specific maneuvers and hopefully at a lower cost than doing it in the airplane, obviously, and get towards your certificates quicker.
And it sounds like there's no instructor involved. This is all self-paced and so on. Where does that play a role in your mind in the total instructional process? And who would benefit from using this and at what point in their training?
That's a great question. So GIFT is in use in a number of flight schools around the country right now. And it is primarily the way it's used is as the practice and repetition step in learning. So it's a maneuver or a task will be introduced by an instructor. A human will teach another human. It's really the only way we're going to learn this stuff. And then they'll maybe demonstrate it, go through those sort of fundamentals of instruction that you're supposed to do. And then they will say, okay, fly this maneuver, let's say steep turns, until you get a passing score. And they can go off with another student. That instructor can go off with another student or go get lunch or whatever. And the learner will be in an environment that's controlled. They're not going to be able to just goof around in the sim, right? Like that's one of the main things that GIFT does is it sort of puts a box around the world. And if you start doing stuff that isn't effective learning, the flight resets, which is, one of the issues that you can have in some of these environments is where they just start playing around in the sim. And so GIFT sort of puts some guardrails on it and drives them to getting to a level of performance that would translate to the airplane. And so it would be maybe they introduce it in the sim, maybe they demonstrate it in the airplane once, do some practice, and then demonstrate it to mastery, proficiency in the airplane. The other place it's really useful is, especially in private pilot training, we kind of do this thing where we touch on a bunch of maneuvers that are required pre-solo. And then everybody solos, and then we go right into cross country. And we have this gap where we don't actually do any maneuver-based stuff until the end when we're getting ready for the check ride. And then you're like, oh, man, I haven't done a steep turn in 2 months. I've been flying cross countries. If you use GIFT, you can allow that sort of maneuvers-based stuff to stay fresher in the background while you're doing your cross-country phases and going through that part of the training. They can hop in the sim for 20 minutes before or after a lesson and get some exposure without the instructor necessarily being there.
Yeah, I'm guessing that in this scenario, a lot of this isn't necessarily loggable, but it helps just build proficiency. What about pre-check ride kinds of things? Would this be useful for someone to just kind of see how ready they are for a check ride?
Yeah, it certainly would be useful. I think we have some schools that use GIFT and as part of stage checks. So they get objective scoring on certain tasks that they use as part of their stage check process in like a 141 environment. It certainly is useful for that. And yes, to your point, it is not loggable, but your average student is taking 70 some odd hours to get a private pilot, even in a Part 141 highly structured training environment. And so if you put 30 of those hours in a sim at half the cost, it makes a big difference.
Yeah, it sounds like a great way to get proficient at a lower cost. Now, one of the things I remember that I thought was interesting and different about your products was remote instruction. Talk about that. What are some of the benefits of that? And then later tell me about some of the issues around that.
So yes, we have a product and a set of tools that will allow a student to sit in a simulator and an instructor to interact with that simulation from not there. So they could be across the world and connect to it via internet. And they start a Zoom call or whatever to be able to see and speak to the student. And then they can remotely log into their sim and start flights and end flights and change the weather and go through that whole process. And there are programs that have started to take advantage of this. A lot of individual pilots that might have a sim at home will, fly with an instructor that they prefer or that they like through this, through a program like that. The issues that have come up really are what's loggable as training in that environment. And unfortunately, a lot of the FAA work is based on precedent. And so let's say you're A&P mechanic, you're doing training for an A&P, you're logging hours for your A&P. This has come up quite a bit of you need to be supervised. Does that mean the guy has to be present with you physically, or can he supervise you from another hangar and you call him if you have a problem? And this is still kind of an open question on the instructional, like CFI side, as well as the other issue is if you could connect to multiple sims at the same time as an instructor. I could have 4 students. Can I provide instruction to 4 individual people at the same time? Is that allowed? I don't know that we have a good answer for those questions at this point.
And so the student would be in the physical simulator. What kind of equipment would the instructor need at their end to be able to interact with a student?
Just a laptop computer. I would suggest a pretty big monitor because you basically get a PFD on the instructor side so they can sort of see the situational awareness of the airplane. And then they'll have a control panel where they're able to interact with the weather and failures and that kind of thing.
But there's no camera. They don't get to see the expression on.
Certainly using a camera, yeah. So that is supported as well. Yeah, you can have a camera. I think it actually is quite helpful to. I'm an instructor. I think one of the issues you would run into is if you don't have a camera, it's hard to read the body language and see the eyes and all that. And I think that's a big part of it.
Yeah, that was exactly what I was thinking. Is we learn so much by looking at the student or client, and we get feedback from their expressions and kind of figure out, oh, okay, we've task saturated this person, or oh, this person is frustrated. We need to explain it a little differently, or things like that. That's great. We'll talk a little bit about software emulation. How do you go about doing that, and talk about that?
So avionics is a huge part of simulation period, and avionics tend to be quite expensive. So to be able to offer simulation at a cost that is not egregious, where we have to come up with a way to provide at least some level of fidelity through emulation. And that's kind of really, if you think 2 or 3 foundational design principles of Redbird for the last 17 years, that's one of them, is that we emulate avionics, particularly Garmin avionics, but they're not alone, like Avidyne and everybody else.
And so you're emulating it to essentially provide it at a lower cost?
Yes, it's 100% about cost. Both hardware cost, it's like a G1000 unit, right? Even without the software, is still quite expensive, more than the simulation costs for a lot of our simulators. And then the licensing fees on the avionics themselves. And a thing we have learned over the years is avionics licensing is extremely complex. Garmin doesn't necessarily own the license on everything. If it was made for a Cessna product, Cessna has some IP as well. If it was made for Beechcraft, so it gets very complicated. And so it's not as easy as, we're going to just give us the software and we'll run it on our own hardware. Like, no, it gets quite sticky quite quickly. So really the path is emulating form function to be able to provide tools that people can train with.
And so do you have your own engineers in-house who are looking at the Garmin product and trying to figure it out and understand it and recreate it, or do you use outside contractors? How does that work?
Yeah, both. So yeah, we have in-house engineers and as well as outside vendors.
So tell us how simulation has changed over the years. What have you seen change during your time working with Redbird?
Yeah, so I was a flight instructor before I started at Redbird, and in the 16 years I've been here, the main change is the use of simulation in training is way more frequent and accessible. There's more sims out in the world. They're used earlier in training, and they're used more often, for sure.
And looking ahead to the future, what kinds of things are you starting to explore, and where do you think simulation is headed?
So there's really kind of two path, well, maybe more than two, but there's a lot of technology that is been developed or being developed that will make its way into GA simulation over the next few years. Really, it's around, number one, high fidelity devices are going to become way more common. So your average flight school right now might have a Redbird or might have a competitive product that is sort of maybe an 80% stand-in. In 5 years, that may be more like a 90, 100%, 95% stand-in for a specific aircraft type, because it just becomes more affordable to do that kind of work because of technology. And then mixed reality is coming. It's usable. There's still some challenges around implementation, but it's interesting for sure.
So tell us a little bit more. What is mixed reality? How does that compare to virtual reality?
So mixed reality takes a virtual world and then a video feed of the real world and overlays them. And typically in flight training, what we would do is use the virtual world for the exterior and then use a video feed of the real world for the controls inside the cockpit. One of the challenges with virtual reality is that if the whole world is virtual, you can't see your hands. You can't interact with the cockpit. You can't interact with the avionics. So mixed reality kind of bridges that gap.
Well, what's really interesting to me is your offices, both engineering and manufacturing, they're all together here in this facility. And I love factories. My first job when I worked for Hewlett-Packard was in a factory, though I worked on the marketing side. And factories are just fascinating. Would you be willing to take me on a tour and talk us through what you have here?
Yeah, absolutely. It's kind of become a passion of mine in the last 6 months as well. So,
okay, great. Well, let's go ahead and start walking around, and you can tell us what goes on here. All right, so we've just left the conference room. I see lots of cupcakes here.
Yeah, it's Valentine's Day is in this weekend, so that we're having a company Valentine's party at lunch today. You're welcome to stay.
I've come on the correct day, obviously. So where are we going to start?
So we're going to start on the kind of and the back end when a product goes out the door, when it's been finished and tested. Okay. So we have a whole system designed to around quality, making sure that we're not shipping products that's defective or has issues, and that's been a major push over the last several years.
Yeah, in fact, I saw a sign at one point we were walking around that talked about the final inspection or the next inspection is being done by the customer. So I guess that's a focus on quality right there.
Yes. Yes, absolutely. It is definitely a focus, and has one of the things we've instituted over the last several months is a 5S process, which is really around keeping things organized, all designed for quality.
Great. So what are we walking into now?
So this is our finished goods outbound shipping area. So we have everything from large crates and pallets full of steel for the motion platforms through parcel boxes, going through UPS to an individual customer.
Got a big wooden crate here. What's in it and where's it going?
So this is a Piper Meridian simulation that's going to a company called Safe Pilot. I think this one is actually going into Houston. It's either Houston or Charleston. And this is one of two that will be going in the next couple of months.
Yeah, and the crate actually stands a little taller than I do. It looks like it's about 6.5 feet tall and probably at least 6 feet width and several feet deep. And this is actually just one of several crates for this particular simulator?
Yeah, so they'll probably ship 4 crates total, and then one large 12-foot by 16-foot pallet.
And where are we headed now?
We'll walk over to the assembly area, which is where we do our mechanical and electrical assembly of components that are either peripherals, so yokes, throttles, that kind of thing, or our desktop simulations. Okay. So we have a team of 10 folks that work here in Austin that do the assembly on all of our products, and they do a good job. And we build it. They're designed and built in a way where we can try to get basically one person, one unit out in a day.
Okay. So I see a gentleman working on, looks like a J, and there's someone over here has got a TD?
Mm-hmm. Yes, yeah. So we'll have a J, a TD. There's also a dual rudder for a large sim, and that all gets done in here. And we're We've moved to a single piece flow system. So instead of, we used to do batches, and towards that quality issue, we've moved back to single piece flow. So they build things start to finish, one unit at a time.
And is it, for these small units, is it primarily one person that's responsible for the entire unit?
So for each assembly inside of that unit, there is one person. So Todd here is working on the final assembly on a J. There are several sub-assemblies that go into that. Those may have been built by somebody else, earlier this week.
Got it. So this is the final assembly wire and test, bringing all the components together.
Yes, exactly. Yep.
Okay, very good. All right, so where are we headed now?
So now we're walking over to our fabrication area, which is where we do any raw material, sheet metal, plywood, tube steel, gets turned into something else. So we do about 25% of our fabrication is done in-house currently. We're sort of in process of bringing more and more of that in-house. We've reached the point where we have some economies of scale where it makes some sense to do that. But for example, we do all of our own fabrication of the shells in-house. We use honeycombed aluminum sheets that are cut and then bent. We're one of the only few companies that really uses this material, but what it enables us to do is make a shell for a simulation that has no internal structure. It's a monocoque fuselage, essentially, and so we can have the structure is provided by the shell itself.
Got it. So this piece of aluminum we see in front of us is roughly, 5 feet square, and I can see it's got 2 layers of aluminum, the upper and the lower, and then we've got the honeycomb in the center. What are some of the challenges with working with this kind of material?
Yeah, we've learned over the years that it can be a little touchy. So the aluminum is glued in there, and so we get them powder coated, but we've had to select one vendor that has an oven that's able to do it at a temperature that doesn't melt the glue. So that it creates some challenges. However, the material itself has got a lot of advantages. It's used in airline Part 121. Boeing products for floors and walls. They're all flat pieces that have no bend. We bend it, and I think we may be one of the only ones that bend it. So that adds some complication, but it's worked well for us for the last several years.
Okay.
We just brought in this bandsaw actually to do some cutting, and we have a router table, a computer-controlled routing table, where we're now able to do all of our own switch panels in-house. So the faceplate that goes on, where the avionics live, right? Is now we're able to do that all in-house, and we literally today just got a huge flatbed printer to be able to print the labeling on those in-house, and made some good progress so far.
Okay. Now, where are we headed to?
So let's go over to the wire room, and then to the PCB room.
Sounds good. Now, earlier we walked through this area and we could hear saws running and things like that. Sounds like it's a little quieter, though. We've got a lot of loading docks here, trucks backing up.
Yes. Yeah, this is the inbound receiving area where all of our inventory parts and materials come in, and it can be quite busy.
And we've got really high ceilings here, so I see goods which are stacked up, 15 feet high, well above us?
Yeah. Yeah, and that's if we expand, one of the things we'll end up doing before we get more square footage is racking to the ceiling, because they make forklifts that will go up to 38 feet. So that's where we're kind of, if we need to add any more capacity over the next several years, we're going to go vertical before we go.
Got it. Yeah, it's a pretty tall ceiling here. Any idea how high that is?
I don't know, no.
Yeah, I'm guessing we're looking easily 30, 35 feet, so a lot of vertical room to expand here.
One of the challenges, given the number of products we have, the number of airplanes we emulate, is that we end up carrying a bunch of demand, or carrying a bunch of inventory. So we have a Piper Meridian that we are going to probably end up shipping 2 of this year. But it's been 7 years since we shipped one before. So some of the inventory is from 7 years ago, but now we've added more. And so we end up with a lot of stuff on the shelves for a long time, unfortunately.
Got it. So tell me what we have here.
So these are frames for switch panels for our large sims. They've been manufactured in-house as well, using 8020, which is an extruded aluminum material that can be cut and bolted together to create. It's actually marketed as an industrial erector set. Makes it super flexible. And then once the frames are built, it'll go into our wire room and we'll wire up, put in our wire harnesses, power supplies, USB hubs, all that kind of stuff.
Yeah, and so what I'm looking at here is looks like what is about 6 monitors, I guess, forming a 180-degree semicircle around where the pilot would sit, and then not tons more than that. So this is kind of looks like the very initial stage of assembly of a large simulator.
Yes, yeah. So this is where it sort of starts, and then they'll add in all of the switches and knobs and buttons from there.
I'm curious, how many simulators have you shipped over the years?
We're probably at about 5,000 total, if you include both the desktop units and the large sims. We're at almost 2,000 large sims.
So it sounds like that's really the main focus, or at least the main revenue component is the large sims?
Probably has been historically. We've had a lot of success with the desktop units going into high schools and middle schools over the last several years, so that's become a big chunk of our business. But, yeah, it always changes.
Okay, sounds good.
Oh,
yeah, so we just walked by some folks who were talking about the printer. Tell us about that.
Yeah, so it's a UV printer. It's a printing technology that we've just sort of it's been around for a while, but we've become aware of, and we actually got the idea for it from the folks at Sporty's and their avionics shop that they had set up, and they're using a UV printer to do the labeling for instrument panels for real airplanes. And after talking with them, it was like, we should do that for us, because we have historically got it screen printed, when screen printing is not really the right technology for the level of like the numbers that we do. And so this uses it's like a laser printer. It's like what you have at home, basically, except the ink cures by UV light, a very bright UV light. So we got a big one, a 10 by 6 one. And
that's feet, right? That's
yeah.
That's a pretty large bed.
Yes, yeah, 10 by 6 feet. And it just literally arrived today, and we'll get it set up and running next week.
All right, so where are we now?
So this is the wire assembly room, where we do more of our specific wiring and soldering work for our larger sims, typically. Both the instrument panels and the avionics setup, as well as the motion control boxes and the wiring associated with that.
Got it. And a little quieter in here too, right?
A little quieter in here, yeah.
Yeah, we don't have all the different saws and other machines in here. So
in here we do. This has all been brought in house, and we do all of our own wiring. This was not always the case in the past. Some of this work was contracted out, but now we do it all in house, and we'll put in, you can see build out wiring harnesses for the switch panel, circuit breakers, knobs, buttons, etc. And then there's a number of power supplies and things that go onto the shelves.
Yeah, so we got a lot of different things in the room here, but right now we're standing in front of a gray panel, which is mounted vertically, which is how it would appear. And it's probably, about 6 feet wide, a couple feet high. A lot of cutouts. Looks like the monitors are mounted. And then all kinds of switches have already been mounted into it. All the labels are there as well. Do you know what kind of simulator this is?
So this is an FMX. This is like our standard, most popular unit. And so this is actually where the yoke goes, and that's the throttle.
Now I see one button on there that I'm guessing is not going to be in the actual airplane, and that's the emergency button.
Yes, we do have an emergency stop button, which would be handy in the airplane, but is not really effective.
Yeah, I understand. So it's a very large red button, so I guess if people need to stop the simulator quickly, they can easily push that particular button. And yeah, wouldn't that be nice if we could do this?
It would. Yeah, it would be great. I would have put used to it at least once. So.
Indeed. And where are we now?
So this is the PCB room or solder room, where we're putting the ladies are soldering in transistors and resistors onto PCB board, green computer boards. The boards are printed through a vendor, but then we do all of the assembly of the boards in-house. And this is really where you get into having to carry a lot of inventory based on having to support a lot of airplanes. So we have a different board design for basically every airplane we've ever done. And we'll typically keep several on stock. So if we need to do support work or replacement, even for stuff we don't even sell anymore, we still keep them on stock.
Yeah, and I would guess that it probably makes sense to not just buy one board at a time. So you're probably buying a number of them, even though you're only going to use a relatively small number of them at that moment.
Yeah, I think 10 is about the minimum you're going to have to buy. So, yeah, that does. It ends up adding up over the years. You end up with a lot of excess stuff.
Got it. I understand. But at least you've got it on hand when you need it.
Oh, for sure. Yep, exactly.
All right, so where are we now?
So this is our completions and testing room for the large sims. So all of our QA functions run out of this space, and we have sims units that are being shipped over the next month or so. After they get finished in the wire room, they come in here. We connect the yokes and throttles and avionics panels and do some configuration work, make sure that everything's set up correctly, and then they'll do testing. The team that's based here also does the QA for the desktops and the peripheral units, but the sims themselves don't come in this room very much. The smaller units are usually QA'd online.
Yep, so I see a number of big units here. In fact, I see some interesting, it looks like aluminum hose. Is that cooling? What does that do?
Yeah, that's cooling. That's dryer ducting hooked up to a bilge fan from a boat. And it connects to there's a hole in the floor of our large sims, and it sucks air up, and it goes through that into a little eyeball vents underneath the monitors on the inside the sim.
Now, is that to provide cooling for the monitors or cooling for the pilot?
Cooling for the pilot, actually, yeah. And yeah, it's supposed to, and so if we operate our sims a lot, and in honestly places that they shouldn't really operate, like Oshkosh, Wisconsin, in the middle of July, outside, and so we have quite a bit of experience with it. But we'll hook up portable AC units to that, and you can actually get some air conditioning into the sim through the airflow system.
Wow, that's amazing. I guess I hadn't realized that. So the pilots need to stay cool, and so you've got that cooling built into the sim.
Yes, yeah, exactly.
Yeah, let's head back to engineering.
Okay, sounds good. So we have about 85 employees total, and the majority of them work here, and here in our facility in Kyle. And we have a full complement of engineering teams. So I think there's probably about 20 people total that do some form of engineering. We have software development as well as mechanical and electrical engineering as well.
Okay, now this looks a lot more like traditional office space with the cubicles and nice lighting and rugs on the floor, and so this is very different than the shop floor environment.
Yes, it is. But one of the things we've always done is have the office and the shop co-located. We think it's actually really important to enable faster design and development, as well as making sure that the feedback from the shop flows back into engineering, and we can design and build products that are as best as possible.
Yeah, and it took us all of 30 seconds to get from the shop floor area to the engineering area. So, yeah, I can see that it makes it very easy for people to communicate with each other and make sure that, they're figuring out what changes they need to make and how things actually work and so on. So, yeah, I can see titles of folks here, systems engineer, mechanical designer, and things like that. Well, Josh, thanks so much for your time today. Tell me, if people want to find more about Redbird, where they go out on the web to do that?
No, thanks, Max. So the website is www.redbirdflight.com, or you can shoot an email to info@redbirdflight.com as well.
And I'm guessing you can be seen at some of the major shows, Oshkosh, AirVenture, and also, Sun and Fun, perhaps?
Yep, we'll be at Sun and Fun and AirVenture, and maybe a few smaller ones in between.
And my thanks to Josh Harnagel for joining us here today. You can find out more about Redbird at redbirdflight.com. And just a reminder that I love hearing from you, and I read many of your emails on the show. If you'd like to send me a message, just go out to aviationnewstalk.com, click on Contact at the top of the page. That's absolutely the best way to send me a message. And of course, I also want to thank everyone who supports the show in one of the following ways. We love it when you join the club and sign up at aviationnewstalk.com/support to support the show financially. You can also do that at aviationnewstalk.com/PayPal. We also love it when you leave a 5-star review on whatever app that you're listening to us on now. And of course, if you're in the market for a headset, please consider buying a Lightspeed headset and using one of the links in our show notes, because if you use those links, they will donate to help support the show. So until next time, fly safely, have fun, and keep the blue side up. And remember that you can always go around.
You can